Sometimes hands speak. They speak of passion, of interest, of the right choice and precise action. Choose. Over 250 investing assets. Act. Start with a free demo account. Achieve. Invest wisely. You can touch the dream or just tap it. Fast and convenient withdrawals. Pocket Broker. That's all in your hands.
Fireflies, a million little pieces, feeds the dying light and brings me back to life. In your eyes, I see something to believe in. Your hands are like a flame, your palms are sweet as pain. Let the darkness lead us into the light. Let our dreams get lost, feel the temperature rise. Baby, tell me one more beautiful lie. One touch and I ignite, like a starship speeding into the night. You and I get lost in the infinite light. Baby, tell me one more beautiful lie. One touch and I ignite. One touch and I ignite. One touch and I ignite. So alive, your touch is like a daylight, burning on my skin. It turns me on again. You and I, survivors of the same kind, but we're the only ones dancing on the
Audio Jungle.
Hello, am I audible? Okay, fine. Okay. Yeah, good morning, Dr. Das. Good to see you. Am I audible? Because your voice is not even. Your voice is not clear. No, sir. Actually, you are muted, I guess. Sir, I'm not able to hear. Shall I reconnect with the link?
Sir, yeah, my tone could have camera on. So your voice is not audible properly. He's also saying no, you're not audible. Yeah, on this mic and say that also. Camera and let it go. Yeah.
Am I audible? Please confirm.
Am I audible now? Hello.
Sometimes hands speak. Achieve fast and convenient withdrawals. Pocket broker. That's all. In your your hands.
Did you know that there is a capital city that was built for millions of people but remains practically empty? And that the US wasted 17
Hello, am I audible? Okay. Thank you so much. Very nice introduction, and I would like to share. Okay, okay. I hope my screen is visible to everyone. Okay. Uh, so I'd like to share two updates in my profile. Like currently, I am associated with Zedwork Manufacturing Business Private Limited as a R&D manager, and recently I have defended my PhD from IIT Raipur. Just I would like to share. Okay, so let us start today's presentation. First of all, I would like to thank Dr. Vikram Das and his amazing team for giving me this opportunity to have a tutorial session on thermal modeling and thermal modeling of power electronic converters on this prestigious IEEE Silcon subsection conference. Okay. To avoid any interruption in between the presentation, I would like to mute. I would like to shutting my camera so that we can have a better visibility over the simulation when I will perform the simulation. Is it okay now? Hopefully, my screen is visible to everyone. Okay. Please confirm the visibility of my screen. Is it okay? Okay, fine. So this is the outline of my presentation, which I'm going to cover. Initially, we will talk about the basics of the power electronics and converter, and then we will see what is the importance of the thermal modeling for the development of various types of converter, and then we will see the fundamental of the what we call the flex simulating environment, where we will perform the thermal modeling. And at the end, we will see the thermal modeling of a particular buck converter, and we will take some of the question at the end. Actually, today I'm having my weekly progress presentation at 11 o'clock, so I will quickly wrap up at 10:45. Okay. So let's start with the fundamental of power electronics. Like, what is power electronics? As we all know, power electronics is a very wide domain, and it is covering from your mobile chargers to the high capacity EV chargers nowadays. Okay, so power electronics is everywhere, and it is covering almost all kind of electronics devices. And if we talk about the fundamental definition, then it is the application of solid state electronics for the control and the conversion of electric power. Because there is two types of scenario, like we are having different types of sources and different types of load. So according to the matching of the load, we are converting the power from one form to another form, depending upon the various voltage level, power level, and application, different types of application. So power electronics is playing a key role for conversion and control of electric power. Okay. Depending upon the availability of source and load, we are having different types of power converter. As you can see in this particular picture, like if we are having DC source and like we are having the AC load, then we have to convert from this DC to AC. And this conversion is more commonly known as inverter application. Like in your home application, nowadays inverter is like starting from your home to your PV level. Like we are having the inverter for your home appliances. We are having the inverter for solar photovoltaic, and nowadays we are having the inverter for your EV as well. Okay, and similarly, if we are having the AC load and AC source as well, however, their operating frequency and operating voltage are different. At that time, we are having two types of converter: cycle converter and AC controller. Like your have you seen your fan regulator? Fan regulator itself is a voltage controller. Okay, so there is a AC to AC conversion. However, the voltage and frequency are different. And similarly, when we are converting from AC to DC, it is a rectifier. Okay. And similarly, when we are dealing with the DC to DC conversion, where the voltage level are different from source, in between source and load, that is considered DC-DC converters. Okay, we are having multiple types of power converter. So it is a different types of power converter. Okay, and this is the classification of the power converter based on the different voltage level. If you see, we are having the power converter from starting from the low voltage to high voltage. If we take the example of low voltage, then we are having our mobile phone, our laptop chargers, and our small what we call the automobile electronics, all comes under this low voltage category. If we talk about the medium voltage, then your what we call the telecom application, AC adapters, your home appliances such as AC and your motor control and your EVs, like your EV cars, are comes under medium voltage category. Okay, and if you take the example of the high voltage category, it includes the traction application and power transmission application and factory automation as well. So here, what we can understand, the power converters are available in a wide variety with respect to the voltage and currents. Then let us reason behind for doing the thermal modeling. Why this thermal modeling is very important with respect to power converter. Let us understand. Okay, this power the power converter is very much essential in order to understand what is the thermal behavior of the semiconductor devices in the initial stage of the design. As we know, power converters, power semiconductor devices are the very critical component. Okay, and it requires lots of complexity with respect to its control. Okay, so and whenever we are designing any type of converter, then the consideration of thermal behavior of the semiconductor is very crucial. Okay, so we have to understand what is the operating temperature when we design a particular converter. Okay, so that we can design our heat sink according to the temperature rise in between the operation, so that the heat can be dissipated efficiently, and we can improve the overall performance of the converter, and also we can increase the efficiency. So considering all those points, the understanding of the thermal behavior is very important. The second important is to incorporate the countermeasure against the heat in the design. Like if you're not putting any kind of heat sink in your design, then your semiconductor may get failed if the temperature rising beyond its permissible limit, which is specified by the manufacturer. So countermeasure against the heat is very much essential. Countermeasure includes the design of heat sink, where we are putting the natural what we call the cooling, or we can have a forced cooling, and nowadays we are having the liquid cooling as well, which are extensively used in the EVs. Okay. The next point is the reduction of development time. Okay. So if you are not considering the thermal modeling in the initial stage, no doubt in the later stage you will face some sort of problem which are associated with the heating. Okay. So if you are not considering the thermal modeling in the initial stage, later stage you have to. It will take more time to what we call mitigate those kind of challenges. So it is better you can address those issues at the initial level by doing the thermal modeling, so that you can have a less overall development time. At the later stage, and the second point is that in the later stage, if you're not including the thermal modeling at the initial stage, in the later side, you will face the difficulty in the thermal measurement and what we call its mitigation. Okay. Next motivation is to have sometimes this heating effect may lead to a life-threatening issues. If you are dealing with a very high power capacity converters, at that time malfunctioning, smoking, and ignition of the product are leading to a fire. Okay, so those can be those kind of what you call the accidents can be happen if you are dealing with a very high power level and a very high power converters. Okay, so it is very essential to incorporate thermal modeling so that we can have what we call the optimized heat sink, so that we can take the heat from the what we call the heat generating components to the ambient. Okay, and the second point is that the reliability analysis. As we know nowadays, every power converters or every power what we call the product needs the reliability analysis. Okay. If you see the detailed what we call the data sheet, then you'll find the reliability analysis very much crucial. Okay, so if you take the example of electric handbook based reliability analysis or any other method, everywhere this thermal modeling is required. What is the maximum temperature that you attain during the operation of the converter that is required? So to conduct the reliability analysis, thermal modeling is essential. And last one is if you are having the thermal modeling at the initial stage, you will have a appropriate design of the heatsink so that you can optimize the overall size, cost, and efficiency. Hope I am clear at this point. So now let us see what is the adverse effect of bad thermal modeling. As you can see this picture, this we have taken from my lab itself. Okay, initially we have like due to the production challenges, we have not taken thermal modeling into consideration at the initial stage, and later stage we have faced this kind of failure of the semiconductor devices. As you can see in this particular picture, I have put two kind of picture. The first one is the through hole component, and second one is the assembly component. Both are all three are MOSFET only. Okay, so as you can see, initially we have not considered the thermal modeling in our design, and just because of the what we call the different issues in the gate driver circuit, we have faced this particular failure issue of the semiconductor devices. Okay, like we are nowadays, these MOSFETs are available in different types of packages. Like if I would like to show what are the different packages. Okay, like Mauser. Mauser is one of the key website where you can find out the different types of component. Okay, so you can see here this what we call the Infineon SMD package is there, and this is the MOSFET from the Vishay, and we are having different types of SMD components we are having, and we are having the through hole component as well. This is one of the popular package that is more common known as a TO247 package. So we are having variety of the semiconductor devices. So intentionally, I have put two types of two packages I have used, the through hole and SMD packages. Okay. So you can see the failure of the switches just because of the bad thermal modeling. So now let us understand what is the heatsink. Heatsink is exclusively used to take up the heat from the component where it is pulled, where the heatsink is attached, and it will dissipate the heat from component to ambient. Okay, so that the temperature of the semiconductor component can be maintained within the permissible limit. Okay, so generally we are having a component and heat sink, and the next important thing is the thermal pad. Thermal pad is put in between the what we call the component and your heat sink to avoid the gaps which are available in the heat sink and surface of the semiconductor components. It basically fills the voids and provide the proper thermal contact in between the what we call the semiconductor devices and your heat sink. Okay. Now we are having variety of heat sinks available in the market depending upon your application and depending upon your what we call the package of your MOSFET. Okay, as you can see in the left hand side, we are having the different types of heat sink which are used for SMD type of MOSFETs, and second one is this type of what we call the heat sink is used for the through hole packages. Okay, so we are having different types of heat sink based on your heat requirement. What we call the available space. Sometimes we are having a very less space to accommodate the heat sink in our design. So the proper selection of the heat sink is very much essential, and proper selection of the heat sink can be done only after the thermal modeling of the converter. Okay. Let us see what are the different benefits of the thermal modeling. Like it is used for the heatsink design. Like no doubt, if you are having the thermal model ready of your converter, then you will design you will select your heatsink very quickly. And if you're not considering the thermal modeling, definitely you will feel a permanent damage of the power component in most of the cases. And you cannot we can have a performance optimization using the thermal modeling, because we are incorporating the what we call the entire thermal range of the semiconductor devices. Reliability improvement. No doubt, if you dissipate the heat during the operation, then definitely you will improve the what we call the reliability, because you will have a what we call the temperature control over the semiconductor devices, and that will improve the reliability. Efficiency enhancement. Like if you dissipate the heat from the semiconductor devices quickly, then we are having a very less losses, and which will increase the efficiency. Safety assurance. If you're not considering the heating effect, especially in the higher power level, there may be a chance of getting fire, and that will be a difficult case if somebody is working around the converter. Okay, cost reduction. No doubt, if you are considering your thermal modeling at the initial stage, there is a less chance of failure of your converter. That will reduce the overall development time, and also it will reduce the overall development cost. of what we call the it is more commonly known as a prototype cost. Okay, and definitely will increase that your development time. Okay, so these are the some key benefits of the thermal modeling. Okay, so let us see how we can use this Plex environment for this particular thermal modeling of our converter. So Plex stands for piecewise linear electrical circuit simulation. It is a software tool for the system level simulation of electrical circuits, and it is especially designed for power electronics, but no doubt it can be used for any electrical network. The main key importance, we can see the key advantage of Plex is it is very compact as compared to other Simulink environment. It is very compact, fast, and allow full functional free license up to 3 months. Anybody can download from the Plex website, and you can use it for 3 months. And if you're a student and you are having the agreement with Plex, then you will get a 1 year free license. Okay, and the application of Plex, it can be used for any application, like it can be used for renewable energy application, automotive, aerospace, industrial, traction drives, power supplies, or EV charger as well. You can use anywhere this Plex. Okay. And the next key feature is it is having its own real-time simulator. If you want to do the rapid prototyping, and if you want to test your overall performance of converter or your control algorithm, you can check with the real-time simulator which is developed by the Plex. Also, it provides the compatibility with microcontroller boards such as TI and ST. You can have so that you can check your real-time validation of your proposed hardware. So this is all about Plex, and this is the key references that I have taken for this particular talk. Thank you so much, and now I am switching to the Plex, okay, so that we can understand how we can use the Plex. So recently I have downloaded this Plex, that is why it is showing this what we call the license issue. But if you open the license manager, you can request from the web form. You just put your details here and your official email ID, then you will get the 3-month license free of cost, even though sometimes they extend up to for 6 months as well if you request sincerely. Okay, so I'm just starting the demo models. So it is the first window of the what we call your Plex whenever you're opening first time. Okay, and if you want to build a new what we call the workspace, just go to the file menu and go to your new model. Okay, it is a schematic workspace of the Plex where you can use it. It is very much like this workspace is very much similar to your other Simulink environment. Okay. And here also you will find the library. Most of the libraries are here, are similar to some other platform as well. Like if you see this power semiconductor devices, you will find all types of power semiconductor devices, MOSFET, IGBT, and your TRIAC and all. Okay, so you'll find here. So most of the components are similar to other what we call the Simulink platform. Okay, so I would like to show the thermal modeling, how we can perform due to some time constraint. I was showing the demo model which are available here. Okay, but honestly speaking, this demo model can be extended for your own work as well. Okay, so that you can model your own converter. Suppose if you are having a new topology, and if you want to do the thermal modeling, you can do by this way. Okay, so I have opened this particular pre-existing model, that is a example of the buck converter. Okay, so here you can see the buck converter is model, and the heat sink, which is nothing but a isothermal layer that function as a surface of equal temperature, and it absorbs the thermal dissipate. It basically absorbs the heat from the component where it encloses, like currently it is enclosing this active part of the converter, which is IGBT and the diode. Okay, so it will show the temperature directly. Okay, and if you want to see the temperature and other parameters, okay, just put on the simulation, start the simulation. Okay, now if you want to see the temperature of these two particular components, just click up here. Now you can see see the temperature of the IGBT diode and the heat sink. Okay. So in a similar manner, you can perform your own thermal modeling of the converter. One thing that I would like to emphasize on you, suppose if you are having a specific type of what we call, uh, suppose I am working on the Infineon platform. If you are working on some other platform like on Semi and ST, any other what we call the manufacturer of the semiconductor devices, then you need to add the thermal description in the power semiconductor device. What you need to do, just double click on here, and here you will find the thermal description. Okay, so how we can perform currently, if you see, it is a 3D lookup table which incorporates turn-off losses, and it is a 2D lookup table which incorporates the conduction losses, thermal chain, which is a thermal description of the particular semiconductor device, and with constants, variables, like in this case device voltage, device current, and temperature we need to provide as a variable. Okay, then automatically it will calculate the temperature of the particular devices. And suppose if you are having a new thermal description, if you are having the new type of semiconductor devices, which is where the what we call the parameter are different from the existing one, then what you need to do, you need to take that what we call the data sheet and just put all the information which is required for turn on, turn off, conduction losses, and thermal chain. All those informations are readily available in your data sheets. So once you have put all those data, just click on OK. Okay. Then you just add those thermal description, just save anywhere in your desktop or in your any folder, and call those particular description using this particular called Plex preferences. Okay, so here you will get the dialog box of thermal. Okay, so by clicking this particular menu, you can add your thermal description here. Okay, and that once you add the thermal description, it will again show in your thermal description here only from the library. Okay, then you can put those thermal description here, and you can what we call the configure your switches as per your data sheet, whatever you have, because all the data sheets are not available readily. So sometimes we have to provide manually all those data so that you can get the temperature of a particular device. Okay, and some of the manufacturers are readily providing the Plex model. If you go to the Plex website, you will get the Plex thermal models. Okay, just type Plex thermal model. You will get the thermal models of different manufacturers like Fuji, Hitachi, and Infineon, Macrochip, on Semi-ROM, Semicron, Texas Instruments. There are a wide variety of what we call the thermal descriptions are already available. Just download it and put it in the preferences, what we call the in Plex preferences, so that you can add those description in your semiconductor devices. And later on, you can have your own design of power semiconductor devices. It is a base example, but this particular simulation can be done for any type of power converter. And according to the temperature rise, you can select your appropriate heat sink. Okay, and that's all from my side. And now I'm open for the question if you are having any questions. Hello. Hello. I'm open for the question in any kind of doubt, although it is a very fast session. I understand because the time constraint. But you can connect me at my email ID if you are having any kind of doubt in the later stage, so that I may be happy to solve your queries in the later stage. You can drop a mail on this particular mail ID, This is my mail ID. You can drop a mail so that I can understand your problem and I can give some solution which may be helpful for your work. So I'm done from my side. If you're having any kind of doubt with respect to the thermal modeling, we can discuss now because I have given 5 minutes for the question answer. Dr. Bikram, is there any questions from the participants that I can address?
Hello.
Yes.
Yeah, thank you so much, sir. As of now, we don't have any questions from our end.
Okay. Okay. So thank you. Okay. Okay. Thank you so much. Thank you all the participants and especially thanks to Dr. Bikram. Okay. Thank you so much.
Thank you so much, sir.